of Allah, the most gracious, the most merciful. Today we will talk about the first thing is if you open the file and look at the block specific to this function. This is the first thing it needs, which are these two. Okay, and it will scan if these two are present. As we know, in the fuse file, it can be achieved in another way. In the fuse file, there is something like RXP, which belongs to ABB, which brings the measuring core and reference core and connects the reference to U1 and the measuring to U2. Then it takes an output contact when U2 is less than U1 and takes an output contact when U1 is less than U2. But here, the fuse file inside the relay itself and the internal functions inside the relay do not work in another way, and it does not work how it tells you. If I have voltage on the power circuit, indeed there is a cut. In this case, my emergency will rise and the voltage will drop, meaning this problem caused a change in readings, right? But if I have a sound circuit and everything is fine, and the problem is only in the secondary circuit of the VT, so what will happen is I will find myself detecting a single phase, for example, a fuse in, or for example, the VT MCB tripped on a phase, or perhaps I have a wire that got cut, so I will find burn. There is a problem in the secondary circuit of the VT without there being a problem in the secondary circuit of the CT. So why does it detect? It detects the negative sequence voltage, or the zero sequence voltage. In the presence of negative sequence or zero sequence without a change in the current, meaning without a change in the current, the relay does not detect either negative sequence current or zero sequence current. In this case, the relay knows that there is a problem in the secondary circuit of the VT, which is the VT phase failure. Based on this, the relay must block all the voltage-dependent functions. That's why it is necessary to connect it to three-phase voltage and three-phase current. These service voltages are obtained from the same place, from the same signal matrix analog input that originally provides to the distance protection. You will find it here. This is channel 2790, red, yellow, blue, which originally supplied the distance protection block. If you look here, you will see it. Here we move to impedance protection, which includes zone 1, zone 2, zone 3, and directional protection. And all that is fed by the signal matrix analog input. Of course, it is organized by the phase fuses, and the current is taken from the same line current that feeds the distance protection. After that, there is a virtual signal, a virtual input, digital signal, which feeds the CP close function, the line disconnector open, and block trap. We will read the logic and MCP open, which feeds the MCP trap. Which on is the one on top? We will see its role as we read, and I have the one, that is the one. There is a block Z, which is a block on every different function from the internal block that connects these functions, like the phase selection, like the 4, 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 like the 4. Like, for example, the weekend feed. All functions dependent on voltages can take a block on the undervoltage, and if it takes this block U or the other output, which is a general start for this function, it blocks on the undervoltage. But at the same time, sometimes we will come to read, for example in the impedance protection, we will find something like switch on default, not one of the fuse fail that blocks it. So here, for example, compared to this, look, it comes out like this here at phase selection. You will find phase selection. One of the fuse fail works on the block. You will find in every zone a phase failure that blocks, and here a phase failure that blocks, but you will not find that on switch on default. Why? Because switch on default usually does not operate when we make a cross command and look at impedance, meaning this signal comes to it on Z acceleration. And where does it come from? It comes from zone 2, and therefore if there is a phase failure in zone 2, it will not work, and consequently the Z acceleration signal will not work, and therefore switch on default will not work. And in this case, there is no mere activation in the phones. But I need to be aware that I will activate the station at a voltage with something like the UI level. The UI level means that I gave a manual cross command and the breaker closed on low voltage and high current. It appears here that I must be aware that I have a certain condition, a fictitious condition, which might cause the voltage to drop and fluctuate with a certain load, right? Am I wrong? So I must apply a block, is that correct? Let's go to our function. I have a three-phase system, which we will see in the logic. When, for example, the phase value drops for all three phases together, it then outputs the signal called high three phase. Here you have the deadlight detection for single phase and deadlight detection for 3-phase. We will start our online detection, the online debug, and look here in the manual at our logic. Here, there are some things in the logic that add both signal block Z and block U, and some of these things only add block U without adding block Z. Let's look at the first things that are always present in the format and test them, and then we will see the other things. The first thing that adds is when we enter the settings. This function starts with operation on and the I base, the base current, which is like the ST 2000 amperes, and the VT 132 kilovolts, which is the primary in amperes. And my video does not learn 32 kilovolts, which is separate from the other. After that, here the first thing is the operation mode, which tells you your operation mode. Have you chosen the detection of fuse failure through checking the voltage and the current? No voltage. Zero sequence nor current. Zero sequence nor it comes. Zero sequence voltage. Zero sequence current or it comes. Negative sequence voltage and negative sequence current. Take the one with zero sequence. The operation mode here will come as zero sequence voltage and zero sequence current, or will come as negative sequence voltage and negative sequence current. All right, let's take the one that comes as zero sequence. I chose U zero sequence and I zero sequence. They tell you that as long as it depends on zero sequence, you must have a neutral point for the VT and it must be isolated. The VT must be isolated to show the component of what? Of the zero sequence. All right, this is excellent. Now I got here. Now one. This one here came to you. The OR gate gave you one. This one here is coming to the AND gate and it tells you here fuse failure detection zero sequence, which means that I saw a 3V node, meaning there was an unbalance with a value of 3V node higher than the 3V node present in the setting, which is this one here. And at the same time, I didn't have 3I node, meaning there was no unbalance in the currents with a value of exceeding tall 3I node. This means that I have 3I node higher than this threshold and 3I node lower than this threshold. In this case, this logic here will give me 1, which will go here to this OR gate, and this OR gate will give me 1 here. This one will go and write the block U. And at the same time, it will come here to write block Z. But to write block Z in this case, it must not have seen any dead fault for 200 milliseconds. What does this mean? It means, God forbid, you are closing the breaker. The observer sees a note without seeing any note, not considering it a solution in the swing until after 200 milliseconds, from not seeing that the line was dead. This means that it must have seen the line as live, not seeing any dead phase, meaning all 3 phases must have been live. Okay, where do the dead and live conditions come from? This is the level considered dead, and this is the level considered live, meaning we must see a level higher than this threshold or higher than this threshold for 200 milliseconds to see dead. We must see a level lower than this threshold or lower than this threshold, and all of this will be tested. The important thing in this case is to also write from block Z. Well, of course, both of them we will write. You must have the second branch. And where did this second branch come from? It comes from being in test mode, having a block or a block trip, which is not our concern right now. Excellent. Very good. Now what happens if this failure persists for more than 5 seconds? Here, a 1 will come out, and this 1 will loop here. All right? It goes into the indicator. If you have the seal-in option set to on, which is this seal-in option, and at the same time, any phase drops below the setting called use seal in, which is less than this setting. In this case, a 1 will appear here. This process will latch onto itself, meaning after it detects a fuse failure, and the block Z and block U are activated. If you have set the setting C, and any phase is less than C, in this case, this function will latch onto itself. If in this situation, for example, all 3 phases C drop, then all 3 will have dropped. In this case, it outputs a 1 here, and if you have any phase, it outputs a 1 here correctly. This 1 outputs here on this AND gate, you get a 1 here, a 1 here, and a 1 here. So this AND gate outputs the signal called surface. So, when does the surface output appear? It appears 5 seconds after the fuse failure detection through the 0 sequence, plus the CN is set to on, plus you have under voltage on all 3 phases. Let's test each thing one by one. First, I have the relay here. Open the application configuration and minimize it. I have this page here. I will soon empty the fridge to keep it clean and organized. Similarly, I will clear unnecessary thoughts from my mind to maintain focus, just like tidying up the fridge. A dish like this just to die. The world we have here just because I had it before. Okay, the world is like this. Let's see like this. Simply, let's test something, let's test the okay that I started. We put the immersion in the journey so we can test everything. We put the efforts and the immersion so we can move everything if I do it this way. I have an effort. What is the voltage level? The voltage level is 60%. But here I'm talking about, and here it's 5% of, okay, excellent. Okay, now I killed the current. I want to see whose voltage it is. 60% of 66.4 means 39.24. Okay, let's say this is 40, there's nothing yet. The previous will drop, it's not my concern now, I'm checking on whom. On dead logic, I'll go down, go down, go down. Another 4 appeared with me, that I have a deadline on whom. On single phase, of course, go down a little more. Now I have a deadline on single phase, so I have tested the voltage pickup. Okay, kill this voltage and let's move to the current, reverse it. Make the current, for example, 0.2 amperes for instance. Gradually lower this current to the full limit of 0.05, right? Okay, we are at a limit of, for example, 0.06. And then you go down. What do you have there as well? Which is on? And of course the same thing will happen if you go down, meaning let the voltages move together here and the currents move what? Together, come on, give me 66.4 and give me 0 here. So the 3-phase line became live. They went down to 39.84, meaning let's make them 40, for example. And then what happened? It went down with the quality to 39.84. You have deadline detection for the 2-phase and 3-phase. It went down a bit just so the finish is stabilized, just to make sure everything is fine. If you want to check on the horn, set the voltage to 0 and set the planes or 0.1. Then we go down on the planes, close to 0.5. We will see that it also worked perfectly. So we have tested the deadline detection. Now let's test the fuse failure. Sometimes 0.1 on 1,000 phases, sometimes 0.4 on 66 phases, repeated multiple times. So, how much is left for me? 90% of the 66.4, meaning if the voltage drops below 59.76, it should show me who without having a 0.1, which is the 10% that he wrote for you here. That's fine. Excellent. Okay, let's go back here again. We will calm things down. I have safety. I will go below 59.76, meaning 60. And then we go down gradually and slowly from 60. Slowly down and 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 down. 59.27. I program the output, you might see it here. I reach the output, or as you see it, I highlight it. Then context, context, context. How the virus disassembles in the series. A note does not grow beyond 0.1, meaning if I raise this to 0.2, I keep it at 0.1 minus, and then I start to gradually increase. As soon as I reach 0.2, the virus in series A starts to be removed from there. As you can see, the virus in series A is gone from there. This is the natural cycle where you test series A note and series V note. These are the normal cases, but we said now that we have more than one thing. What is this thing? The first thing we said is that it will latch after 5 seconds. When? If a phase drops below the UC now and I have set the UC now to 70%, there is no problem. Multiply 70% by 66.4, which means 46.48. Good. I will return this like this, and I will see why here. Like this. If it drops here, below 59.76. We will make it 50. You see, face fit. Okay, excellent, but it doesn't latch. For example, here, it is more appealing than the liquid mortar. Come, lift the table, make it point C, it will go face fit. But we return it again to point 1. It will return to face fit, right? But lower the table below 46.48. Okay, first make it 46.6. A simple financial point. Okay, make it 46.6. And count 5 seconds, or from now 20, 29, 30, 31, 32. We've counted 5 seconds. Lift the plane again, for example, above the first point, for good measure. Lift the theft knob to the first point. A small point? Agreed. It will also unlock for you, who has the views, return the current as it was. Then go down to 46.4, meaning we are, for example, at 46.4 only. And wait on it for 5 seconds. For example, 1, 2, 3, 4, 5. Like this. Wait on it for 5 seconds. Lift the emergency again. The fuse didn't go. It will remain locked on itself. You understand me? It will lock on itself until when? Until you return it above the pile, which is, didn't you say, for example, knob 10, go above 9, 50.7, 6. Okay, now another one comes, for example, another one comes to me. Here is point 1. Lift this now. You will raise 50 and it will not drop to Palestine. You will raise 50 and it will not drop to Palestine. You will raise 50 and it will not drop to Palestine. You will raise 50 and it will not drop to Palestine. You will raise 50 and it will not drop to Palestine. You will raise 50 and it will not drop to Palestine. You will raise 50 and it will not drop to Palestine. You will raise 50 and it will not drop to Palestine. Get lost 3, 4, 5. When you raise the pilot, do not break the commitment because the voltmeter is less than the commitment. Because the commitment is less than the commitment. Because the voltmeter is less than the commitment. Because the voltmeter is less than the commitment. You advise me to release the latch at 59.76. Yes, because it released the latch since it is above the UCLN. And at the same time, it didn't see in the UCLN because the pilot here is fast. The note is higher than 0.1. Right? Or am I wrong? Here the fast note becomes 0.2, so it doesn't see in the UCLN. You know, if this went back to 0.1, it wouldn't send at that time. And it wouldn't send unless it goes above 59.76. Okay, let's set it to 60.4 times. Whose segment is this? This is the latch segment. We want to differentiate between the instant release of block U and the release of block Z after 2 milliseconds from the moment of injection. Let's see the difference between them. Now I choose to work in sequence on page 66.4.1. Is everything clear so far? Okay, then on the second page, I will inject a fuse failure here, or 950, but at 0.8, and the current is also at 0.8. Nothing is happening. I want to create a fuse failure. Okay, the current page is healthy, the second page has a fuse failure, and the current page is as I left it, as I named it. So I have given it live conditions for more than 200 milliseconds. Naturally, if I inject now, what will happen is that the stop will occur instantaneously due to the fuse failure. We will lower it a bit. The 950 should be 7.6, not 8. Why? 950. What about the 550? What happens then? The fuse works instantaneously. Why? Because I was giving it live, right? Of course, I was giving it live for only 100 milliseconds. When you go to the second page, it won't give you an instantaneous fuse failure. It will give you a failure after another 100 milliseconds. Why? Because according to the logic here, it is a condition in the middle of the hell. And this deadline has passed on the off delay timer. So the deadline on the first page became 0 and the timer continues to count to 200. Out of the 200, only 100 are in the first page. So it moved to the second page. Here, this condition still outputs 1, so the AND gate here outputs 0. The AND gate outputs 0 after an additional 100, and the output of the timer here becomes 0, so the output of this NOT gate becomes 1. And here you have 1, so what does it output? Block Z. This means that if I had injected directly from the second page, it would have gone to the time of 200. Why? Because in the second page, I will tell it to delay more than 5%. And also, a voltage trick greater than 60% of the U-bus. So for it, it becomes a wave. And for it, a phase fail. But for the phase fail to work, it needs to see a wave for no less than by the 200 milliseconds. That's why the first fiddle sees the 200 milliseconds. And after it finishes, it finds itself indeed a wave and stable, seeing a phase fail, or what? it gives you a stop immediately. This is the part currently present here, but this U block seems to appear as instantaneous and has no connection or relevance to our story in any way. This upper part, in addition to the series phase we mentioned, as we proceed, let us take a closer look at how it seemingly appears from the first page in detail. The first page is to change the three-phase voltage simultaneously. If I injected like this, no, sorry. First you must simulate a phase fill condition. Keep it like this, I will change the three phases, meaning I injected like this. It went down to 55, so it saw a phase fill. If this phase went down less than the seal, it remains the same. If this phase also went down. When the first phase goes down, the three phase immediately appears here, when the three phases go below the U seal, which is the information present here. These three phases come out from the end gate. If after 5 seconds it appears here, plus the U seal, what is its function? I will explain it. Plus, if all the phases are lower than the U seal, then these three phases will continue to rise. If you go out to play, honestly one comes here. Plus, if any phase remains below the UCLN, it will continue to rise to three phases. So if I go back and say the relay, I made this phase rise to 50, the three phases won't go. Unless all three rise above what? Above the 46 point mark, until the UCLN when all three rise above what? At the same time, this one came to you here like this, to your level, here. The one that came after 5 seconds came to me here, and I did it. And all the phases brought you here. So who came out for you? In the same time. This one came to you here like this, to your level. When you came with any small phase from UCLN, you kept latching onto yourself, meaning even if this scenario disappeared, you still jumped. Why? Because any small phase from UCLN, when does the service reset? When all the phases exceed who? The UCLN, all the phases. And keep in mind, this service doesn't activate until 5 seconds after the detection of the fuse failure. After 5 seconds, meaning before those 5 seconds, whatever happened won't be seen. So look, for example, if I came here, I give 66.4, 66.4, 66.4. Look, sir, I injected like this, achieved like this. Look, I did this at 40, and this at 40, and this at 40, yet you find the slave still hasn't appeared. Why? Because the fuse failed once. Actually, the fuse fail should be present for 5 seconds. So here, 60, 60, like this, fuse. I leave it first for 5 seconds after the 5 seconds. If I made the three phases a little less than 3 phases, I get 3 phases. 3 phases appear after 5 seconds from the detection of the fuse fail. And after the 5 seconds, my 3 phases are clear. This means that up to now, the fuse fail detects the single phase and 2 phase problem. So if there is an issue with 1 phase or 2 phases, it sees them. It cannot see the 3 phases with the logic we have in this manual. How do they see it? There is another logic. We need to see the residual zero sequence or unbalance with the negative sequence. In the negative sequence, we need to see the residual zero sequence or unbalance. We need to see the negative sequence. So what did you notice? They switched places with each other. Do you understand that? Up until now, what is this? This is the what here, and then the what. This is the normal logic, and this is the logic present in the format as you can see, and it works in the same way. However, there are some dimensions like in the VTM-CB trip. We will change the configuration and see on the VTM-CB trip part, but I can follow these dimensions from the things that output the block U, which is the line disconnector open. This means U can reach the signal here. If the line disconnector is open, it will drop into the sphere. Here, if the line disconnector is open, then you have already moved to the page. All right?